Hello everyone, welcome back to another tutorial session on chaos engineering. Today, our focus gonna be that how harness can help you measure your resiliency score by using our inbuilt feature called resilience probe, and we will talk about the various scenarios, and we'll also show you a demo, and we'll also show you how you can set up your own probes so that you can get a mathematical score which you can use internally to benchmark the resilience of your application. Before we go there, I would just like to touch upon when it comes to chaos engineering. So when this practice was started, and during the initial days, the focus was much more on creating scenarios and running experiments. But as soon as you mature into your practice of chaos engineering, the other important aspect of chaos engineering is to understand what is the resilience of your application. How resilient is your application, right? What is that? So like how your efforts are going to help you improve your resilience. So to go on to that level, it is very important, first of all, to have a mathematical construct which where you can get a score and you can measure that score and perform your iterations to reach to a level where you can show this to your management to get an executive buy-in and also buy-in from your internal teams. And that's where harness has come with a concept of probes, where you can write your own probes, whether it could be http a command probe or your apm monitoring queries, so that you can go ahead and reach that score. Now with that I will just quickly share my screen, and we will just walk through the harness ui on the process, how this setup is done. Now, going back to the harness UI. So here, as you can see, you have an or section for overview, chaos experiment, and on the left hand side, you will find a concept of resilience probe. Now, what does it mean here? So if you click on this resilience probe and you create a new probe, you can select different infrastructures where you are running chaos engineering. In today's demo, we'll be focusing on Kubernetes and its well-architected framework. So as you can see, for Kubernetes, we have different options. We have an option for HTTP health point, where you can go and configure an health point for your application, and you can measure the response code or the response body to do the assertions. The other options that you get here is Prometheus query. There is also an option for tools like Datadog, Dynatrace. But then in today's video, we'll be focusing more on a very powerful feature that has been used by our other customers very well, in fact, and that is called Command Pro. Right. So in the command probe, you can think of it more like an scripting platform that we are providing, right? Where a user can come and write their custom logic, right, and do the assertions for their business validations or infrastructure validations. Now, coming back to the command probe has two concepts here and how harness works behind the scenes. So for Kubernetes, as you can see in command probe, there are two options that we provide our customer. The first option is if you want to run basic shell commands. For example, you want to print something, right? Or you want to run a command, right? You want to change a directory or maybe cat a file, which is like very basic validations. You just want to check whether this file is present or not. That is where most of the times you will go with an inline command mode. What it means is these commands would be running inline. There will not be any container that would be launched. The other option we have is a source mode, and that is where what is being used by most of our customers. Is a very powerful feature, and we'll show you a sample what it means. So the purpose of source mode is you can write your custom logic in any of the popular scripting language like Python or Go, and then you can Dockerize that, right? So you can create your own custom image, and then you can save that into a private repo or public repo, right? And then you can inject environment variables on the fly to make it more generic, right? So for example, you would like to know the number of replicas for a particular deployment. Right. So you can have an environment variable for namespace, you can have an environment variable for label selector, and you can calculate the number of replicas. Right. Let's say you want to calculate the pod startup time, right? How much time does it take for my pods to come up once I have deleted them? Right, then you can write your custom logic in Python, iterate over all the pods, right, and provide namespace and label selector as environment variables, right, based on your logic. And then you can calculate the average, min or max, and then you can do those assertions, right? So we will actually cover through that. So just going back to the a sample. So for today's demo, we would like to cover like some of the well-architected framework out of the box validations that we have written for our customers, and which basically tests the resilience of your Kubernetes application. So going back there, I would like to touch upon some of the probes, like for example, pod replica count, right? So let me edit this probe and show you how it is being done. Uh, so you can provide your name. The name has to be in small letters. This ID will be generated automatically by Harness. So even if you change the name, the IDs will not change because IDs are unique. And configuring details. So like I said, we have written a source command probe. And when you create when you write your logic in your custom language and create a Docker, that's where the source mode comes into the picture. Just going back to the first command, what is this command? So we have built our Docker image by using Python 3, and script.py is nothing but the name of our file, which has the code, right? So this is the entry point for the script. And in the comparisons, we support different kind of data types. As you can see, there is a float, there is integer, there is string, and you can have comparison criteria. So basically what this probe is doing today, it is just checking that before and after chaos, what is happening to my application number of replicas, right? And then going back to the YAML configuration, and that is where the core part resides. So you can provide an image, right? As you can see, that is docker.io. It is hosted in our public repo, right? And then this code, this script uses two environment variable, which is one is a namespace, right? Where these pods are deployed. And the other one is label selector because, right? So label selector, you can get the number of replicas by using that. The question which you might ask here is that most of the times as an enterprise customer, you will not go ahead and use a public repo, right? So then how can you provision a private repo, right? So to answer that, you can always use your own private repo like a JFrog, GitLab. So when you use that, the only other parameter, so this YAML, there is no hard and fast rule. There are different parameters that you can pass. So you can pass this parameter called image pull secret, right? And let's say that secret could be my GitLab repo, right? So whatever secret that you have created in your cluster, you can pass that parameter here. So then Harness will use this secret name that you have created in your cluster and will go and pull that custom image, which is stored in your private repo. The other questions which might come is that what all the other parameters that we can pass. So we will actually go back into that documentation a bit later, but I just wanted to show you how you can do that setup. Now, for this purpose of this demo, I'll just quickly go back and so before I do that, I would also like to share some of the parameters. So as you can see, there is a timeout. So what does it mean here is, so this is the time that Harness will wait for a probe to do the execution, right? And the interval and attempt, these two parameters comes into the picture. Let's say when the script or the probe is running, and during that run, let's say if we have encountered a failure, that's where your attempts, think of them as retry, and interval is right for how many seconds should I wait before I do a retry. Then the other concept is here is polling interval, initial delay. So polling interval comes into the picture when you want to run something continuously. So let's say if you're running a chaos experiment and you would like to test let's say a health point, right? What is the how's the health of my application? Then you will have a concept of something like polling interval, where you continuously poll the health point and check those metrics. I will also show you that. And then there is an initial delay. It is always a good practice to have some initial delay, because as soon as the experiment is triggered, it takes some time for chaos to actually occur into your cluster, as harness has to bring its own pods, do the disruptions. So it's always good to have some initial delays. And then there is a concept of verbosity, which is how you want to view the results. So there are two options: info and debug. If you go for info, you will not find whatever print statements that you have written in your script or in your command prompt, right, into the log section, right? But if you go for debug, you will find all these logs as part of your, you will find all the print statements or the debug statements that you have written as part of your script. Then the other important parameter here is stop on failure. What does it mean? So basically, the purpose of this feature is, just imagine you want to run a chaos test. But before chaos test, you would like to do some basic health checks, right? Just to make sure that whether your system is up, right? Whether your health point is up, whether the number of desired replicas are up or not, right? So before starting test, this is one example, right? So now if you configure this, what will happen? Let's say during your test, if harness finds that, hey, some of the validations are not meeting its standards, then the chaos experiment will be stopped automatically, right? So what we have seen with our customers is like they use this parameter for their critical applications, where they don't want to run chaos engineering further if the application is not meeting their standards. Now with that, I will go to another probe just to check, just to show you, which is like pod startup time, right? So this is also one out of the box validations that we have written for our customers. Same logic, right? This is how our Docker file is built. This is the name of our code file, and this is an entry point. What we are doing a comparison here is that my startup time should be less than or equal to 90,000 milliseconds, right? And if you see the same concept, this script uses two environment variables, and we are passing the Docker image that we have built where the custom logic resides, right? And if you go to the properties, same concept: 10 seconds, 2 seconds, polling interval. Like I said, if I want to run continuously, I will use polling interval. Otherwise, it is not required. All these parameters are optional. And the verbosity is debug. Now, I will also show you a health check probe that we have set up. So in the health check, what we are doing, we are calling our application. It's a front-end application. We are checking the health point. We are monitoring it, and we are doing the comparison whether this health is, whether the application is up or not. In the configure properties, same concept, right? Now with that, I will also show you a running execution here that we have already run this experiment. So let me just show you some of the results. So once your experiment is run, and if you have those validations, and because of these validations, you will get a valid resilience score. As you can see, my resilience score for pod delete is 75%. And why it is 75%? Because I have written 4 very good validations, and out of which 3 validations passed, but 1 validation failed. Right. So just imagine a scenario with pod delete. What is that we are doing is that we are checking whether if I delete this pod, will this pod come up in different availability zone, right? How many replicas are there for this pod? What happens to my health point? So just imagine if I just have one replica, then of course my health point will fail, because once you delete a replica, there will not be any service available. But since we had multiple replicas, we are multiple replicas, that's why our health point is up. That means our application was still accessible, right? And the pod startup time as well. I will show you the reports here. You can view the details here as well. What is that we are doing? But the other question would be how I can get this as part of reports. And that is where, if you click on this option of view report, you will see a detailed report with your results. So my availability zone check failed because my expectation was my pod should be part of 4 availability zones. And again, this is just for testing purpose, but it was actually part of 3 availability zones. My actual replicas were 3, but I was expecting it to be greater than 2. So that works. And my health point was always up. And as you can see, it ran 7 times because it was running continuously. And the other thing here is pod startup time. So my so as you can see, my pod startup time here was 60 seconds, right? And the expected value was 90 seconds. So you can download this report as well, and you can share with your team. So these kind of validations that you can do. Now coming back to the documentation here, which is configuring command probe, it is available in our developer docs. You can see an option here is command configure command probe with source parameters, and that is where you will specify the image, the environment variables, and different parameters. Just to answer your query, because you let's say you are doing an API call, right, where you want to pull some data from external system, or let's say you want to pull a query from New Relic, right? And as you can see that right now we do not have out of the box support for New Relic, but then that's where command probe comes into the picture because it is such a powerful construct where you can build your own custom code. You can call any APIs, you can write whatever logic you want, and you can actually change that, right? So that is where if you go to this documentation and look here, you can see that how we are solving this problem. We have built a custom image, we are passing these environment variables. And now when it comes to the secret, for example, API key and all, you can always create your secret in a similar way how you do in Kubernetes, and refer these secrets from the Kubernetes secrets. As you can see, that is how we are referring. So that is what we had of how Harness helps you creating resilience probe and gives you a resilience score, right? For and as part of this tutorial, the other thing what we also wanted to specify is that this is one of the best practice that we have seen across the industry, that where most of the customers are actually now going ahead and writing those validations to get a mathematical score so that they can measure their KPIs. Thank you everyone for watching this video. Stay tuned for more training videos.